Hello everyone, my name is Dmitry. I'm leading Surfalytics, and the goal of Surfalytics to help you gain knowledge and be successful in your data career, even with no prior experience. Yeah, and right now we're doing more like foundational trainings, and you might guess why we start like doing command line interface, why we're doing Git systems, why we do the Docker today. And because I believe it's very important for data roles, and this is how the most of the modern companies operates. And as soon as you learn those basic concepts, the better will be for your career. That's why we just gently starting using everything like Git, CLI, the Docker, even without full understanding what is it. It just doesn't matter because the matter is the skill. And to build the skill, you need the practice. But first, we need to do a bit of the job. So for this lesson, you may need download the Docker client app for you to run the Docker locally. But before doing this, I already download this, and I can launch the app. So this app will shows me everything related to the Docker. So we have containers, images, and we'll talk about what is container, what's the images, what's the registry, and talks about some alternatives. Because another benefit of understanding the Docker, the same as understanding CLI and Git systems, is your ability to, in any organizations, your ability to look into the code base and understand what's happening. Because the sooner you understand what's happening in the organization, the sooner you can contribute, and your contribution be more valuable, and it means you will be more successful. So this is a bit like shortcut to your success career, and that's why I spend so much time on doing this before actually start teaching you what's analytics and everything else. Yeah, this is the Docker desktop app, and you may need the same. Okay. Hope you can download from their website and then you can use it. So the step number 2, what we're gonna do, we open our IDE, so Visual Code. Here in Marketplace, we even can download the Docker app. That might be very helpful because it will tell us what local Docker containers we have and images and everything, like all the informations that's available. And you see, I have my fancy CLI terminal open. It's connected to the Git repo. So if I type git status, it will tell me already, oh, you already modified the file readme. Yes, I did, because I added the instruction for this lesson. So the Docker is installed, so it has even tutorial. I don't have any images. I'm not connecting to any registry. But before, let me share one file that was prepared by Nikita, who is an active member of Surfalytics community. And this can be very helpful for us. So this article is not yet published, but the general idea before diving into containers, you should know what is the virtual machine means. Because the virtual machine, for example, currently I'm running on the macOS. My laptop is MacBook. My operational system is macOS. You might have like different laptop or different PC with operating the Windows operation systems, or maybe you even have the Linux, doesn't really matter. But assuming on macOS, I want to play the old games that only working on the Windows. For example, recently I had the challenge. I want to play the game. If you're curious what's the game, I can tell you what's the game. So I want to play these games, Worms World's Party. And this game, yeah, when I was younger, I liked to play it. And I really like physics of this game. And the thing about this game, I can download the Steam client. Unfortunately, the Steam client only supports the Windows operation system to play this game. And we even can see it here, like Microsoft Windows. Unfortunately, I didn't see this on macOS. So for me, to play this game, what I need to do, I need to find the way to run the Windows on my laptop. And for MacBook, there are two ways of running Windows. So the one way, we can literally install like operation system on top of hardware, and then we turn on the computer. We have the options like choose the Windows or choose the OS. But I don't recommend to do this on your MacBook Pro. Instead, there is alternative, so we can download the software, for example, like VMware. We can use the VMware client, or there VMware, or there is VirtualBox. VirtualBox is completely free, open source by Oracle. So this thing give us, it's like we're running the applications, and from this application we can take the image of the Windows, and we can launch in the window the working Windows operation system. And then I can like make the full screen mode of this Windows application with the Windows operation systems, and like get the Steam, get the My Worms game and play. Maybe you need this for the work or maybe for something else. The challenge here that usually this virtual machine will like weight 40 gigabyte. And this is my experience with the previous. Then I actually had the Windows machine for exact the same reason. I want to play Worms. Yeah. Then we talk about analytics. We don't need usually to run the heavy applications that requires many resources. That's why we can run something tiny. And something tiny, it's actually the container. So if you got the idea what is the virtual machine, right? And the virtual machine, the idea that I have my physical hardware, right? My laptop, or in data center and cloud computing, you have the physical data centers, and they're running hypervisor operation system. And this let us to spin up multiple virtual machines. Each will have dedicated resources, like it will have guest operation systems, and then we can run. And it will be very heavy. So the examples here, Azure Virtual Machine, AWS EC2 Linux, or on Google Cloud, you can do the same. Or even I can run multiple Windows machines. I can run one Windows like 11, one Windows 7, one Windows 10, and I can run all three in parallel. And also then I will create the virtual machine. I can say, okay, you will use the 100 gigabyte of hard drive. You will have like 4 cores and maybe 8 gigabyte of RAM. Of course, it's limited of how much operation memory I have here. And each machine will be pretty heavy. It takes time to boot. It takes time to freeze. And so it's just not that convenient. The containers, it's like small tiny bits of everything you need to just run the applications. Usually they never had like UI. You don't need UI. They have the terminal, like command line interface, and in many cases just Ubuntu, lightweight operation systems. And the thing is like looks similar, right? You have your physical hardware, or even in some cases you can have just the virtual machine, right? If in AWS I will start the virtual machine like EC2, then I can host numerous of containers. But usually no one does this because you have special services that can run containers for you. And this is what company use in the real world. To operate containers, this process usually calls orchestration of containers. And there are different software and services available. And for example, one of the most popular one, open source, is Kubernetes that was built in Google. But I don't want to go deep in details right now because it's something coming way later in my course, more related to the data engineers. For example, how you want to host different applications. For now, we just really focus on what's the Docker, how to make Docker yourself, how to run and start it, and what's the DockerCompose, what's container, what's registry. So the first word is container. So the container is actually running piece of software with something inside it. Then it's running its container. So, but to run the container, what we need to do, we need to actually come up with definitions of container. So, and today we'll create the definition of container, also known as a Dockerfile. So, and then we have our definition of container, we have the Dockerfile. What we can do, we can create the image. So image is just like we can, for example, we can create container, we can execute all requirements. For example, take this library, take this piece of the code, install those packages, and then it will like freeze it. It will save this image with the goal, for example, then we need to use it for our actual use case. We can instantly run the container. So basically, the first step of building to creating container is to build operations on top of Dockerfile with instruction. And the second, if we have our container, we can find the place we want to host it. For our exercise today, we will use the Docker desktop client to host our containers. And for example, this is architecture of Docker. It's from Docker Overview. So we have client, it's our laptop, what we're using. So, and here we have the options. For example, if we install the Docker, we can run the Docker, we can build the Docker, and we can pull the Docker. And the pull, it's actually very similar to the idea then you do pull from GitHub. So basically, you can clone the Docker image that someone built already for you. And I will show you this. Docker build is actually then you build the Docker on top of instructions. And you can, instruction is good because it's the text written in the very simple format that very easy to save in repo. And Docker run, so if you build the image, you can run it. So registry is a kind of like library of Docker images. For example, if you build your Docker that can, for example, you want to build the game, right? And the game is tiny, so you don't need to big virtual machine, and everyone can run the game on their own machines. So in this case, you can create the game, you can package the image, and you can save this image in the registry. So for example, the DockerHub is known registry for Docker, where we can find many different images ready to use. So what's the key elements we have? We have client, we have daemon. So the daemon is the process that's running behind. So for me to start the daemon on my machine, I need to launch the Docker desktop. As soon as I launch the Docker desktop, we can say engine running. So it means the daemon is running. So the host is provide underlying operation system for containers. Currently, the host is my laptop. The image is the package with application, dependence, and all environment configuration. Container, it's running instance of image. Repository is collection of related images with same name but different versions. Registry is a storage collection of repositories for Docker images. So those could be confusing, repository and registry. So registry is one library, and the repository is a kind of like list of images for a given container. For example, you can publish your game into registry, but if you have multiple versions of your game, for example, one for the Windows, another for macOS or anything, then you will have the repository for them. And another thing, what's important here, they give you isolation. So what it means, so if I have my container and I have the code, for example, that I want to share with my colleagues to test, and assuming I built the code on macOS, that's probably not gonna working on their Windows machine. But if I will package the code in container and I will share image of container with them for the registry, it could be not the public one, it could be the private one. So then they can launch it. So it's kind of like standard that everyone can reuse the images and launch the containers. And also for analytics purpose, for example, dbt, Airflow, Metabase, there are many different services, especially open source services that running inside the Dockers. The benefits of the Docker, so if you have the image, you can launch the container. If container is failing, you can instantly launch another container. In many cases, then we process the data, for example, running the dbt, and usually the use case could be you have Airflow, Airflow have the job to refresh the data. It starts the dbt model, basically just the SQL transformations. And for this purpose, instead of running everything inside one container, the Airflow can live in one container, and it will launch new container based on dbt repo. It pull all the code, it build the container in seconds, execute the model, and then shut down container. It's also very cost effective. The couple things here is the port bindings, because by default when you create container, the container, it doesn't have any access to the internet. And this example of the Docker files, but we're going to build ourselves, right? So usually the Docker files, they treat as a layers. And it basically you build one layer, another layer, and second layer on top of the previous one. And they're starting all from very specific image. It could be start from Ubuntu or with the Python or any other. So it's your like starting point. And then you can start the copy data, you can set the work directory, you can run any kind of commands that very similar that you can run in CLI. And then you can execute instruction for the Docker container. So another thing, in GitHub lesson, what we built the GitHub workflow pipeline, and we saw example that something is running in GitHub, the pipeline. What actually is running there, it's the container, but this container is hosted on GitHub, and what it's doing, it's following the instruction, taking our code and, for example, doing the linting. So that's another benefit. If you understand what's the Docker, you may understand many pieces, because most of the solutions out there, they're not that complicated. They're quite easy, but they're only easy if we can understand the basics. And today we talk about basics of the Docker. And you already have the knowledge of GitHub and CLI that will be very handy today. Okay, now I can go to my Visual Code where I download already the Docker app. We don't need it. So from here, what we're gonna do, and here I already have the instructions. By the way, if you don't know what's Markdown, so Markdown, I already mentioned this, but you need to practice a bit. It's very simple. It has the headers, right? This is like the header 2. And if I have the multiple lines of code, I use triple back quotes, and I can also say what's the code, and it will highlight, because I have here the Python example. Oh, this is the Bash example. This is the Python example, and in this case, it's highlighted. So I also can create the hyperlinks. I can insert the images. I can create the tables, and basically that's it. So, but as I said, always focus on README, because this file is by default open in your GitHub repo. So whatever you want, if you want that someone read you, for example, people, hiring manager or maybe recruiter, whenever they go on GitHub link, make sure you have very good README. And README you will create by using Markdown. And this is not very friendly. That's why I can, for example, open the preview. I probably don't have the, do I have the preview here? No, I don't have preview. In some versions of Visual Code, I have preview, in some I don't. That's why I can always download it. So in my case, I can open the preview. And this is the preview. You see, it's very easy to read. And this enhance preview mode, but what we currently here. Currently, I'm in my main branch, so I can do the git pull just in case if I'm missing anything. And you see, it's already pulling the informations that we recently merged. So every time that you start work, please do the git pull to download all recent changes. Now I'm in the main, and also there is, for example, git app, but it tells me, oh, this on file is modified. Anyway, so we go back here. So the next step I do, you should know those commands. If not, you need to make sure that you can know them well. Yeah, I don't know what's the good size here. And just practice, and there is like less than 10 commands. If you want to advanced cases for Git, just learn what's Git rebase, and Git merge and conflict resolution. So those are very popular questions on interviews. So for here, you remember we have checkout name of the new branch, and we want to call the branch Docker. Or maybe very good practice, I will call it Dmitry/Docker. And we switch to the new branch. I have those nice plugin on my shell, on my Z shell that highlight every information for me, have the colors. Here I also have the additional information. Okay, I'm in my repo. So now we can start to develop. I already put here some commands that we want to write, and I can very quickly create everything here. And this is maybe the way how we're going to work most of the time. But now, because we're learning a bit, so we want to do it with a terminal. So for example, I can write clear command to clear the page. And the one thing I have here, it's more advanced if you never work with the Python. And by the way, the Python is the only language you need to learn after the SQL for your data career. But if you focus right now on the roles like data analyst, just entry-level jobs, not junior. We never apply for the juniors. We just skip the juniors. But whatever, if you want to start learning Python, you probably will know about the virtual environments. And it's actually very simple. But for this, we need to make sure that we have the Python. So if I will say Python version, right, I don't have Python, but I have Python 3. Okay, that's why I have. So the virtual environment, the goal of the virtual environment is some extension similar to my example that I shared in the past about the Docker. The Docker can create as isolation, where we can put all our logics, the code and everything, and run it in isolation. So the virtual environment is kind of like similar thing for the Python. For example, if you create the Python, we use different libraries, for example, for visualization or maybe for data science, whatever. And we want that it would be easy to reproduce on another machines or another engineer. For example, someone do the code review, right? Then they will clone the code on their machine. They want the code should be runnable. And there is no term like dependency hell. Then you have so many different dependencies, some of them conflicting. Someone working for Python 3.11, another for 3.7, and so on. So it's dependency hell. To avoid this, we can, for example, start from scratch. Start from scratch, it means we can create the virtual environment. And this is very simple. So I can create the virtual environment with the name venv. And here we see the new folder. This is my virtual environment. But it's not yet activated. To activate the virtual environment, we can see what's this folder. And this again, like you can browse your code repo in the company and you can see many things like what's .git, what's .github, what's gitignore, what's precommit, right? Now you know all those files. And this is very, very valuable information for you because without understanding what the hell is happening here, actually is everything very simple. So, and here we just create the virtual environment, but we're not yet activated. So to activate this, for example, this command is for the Windows PowerShell. This is for VSL and macOS. So I can run this command. And you see, I'm inside the virtual environment. Again, CLI is helpful for me. Yeah. Now we inside the next thing, for example, because I will use the code, this code that's using Flask. So it doesn't matter what is Flask right now, right? We just want to make sure that this code is working for us as expected. And it requires the Flask. And I may not have the Flask by default installed with my Python. That's why inside my new fresh environment, I can install the Flask. Pip install Flask, it will download the Flask library. So the pip is the command that downloading and installing the packages for the Python. So it's already downloaded. And my next step, because I don't want that my colleagues run it themselves every time, like, okay, this is my code, but first please do this, and like hundreds other libraries. Instead, I can create the requirements.txt file. Again, the new file you will learn, and actually it's very simple to know what is this. So if I will run this, we see we got new file, and it has the flask. It also pinned the version. The pinned the version is very good to avoid any kind of dependency hell. But also you see, while we downloading Flask, it requires some other libraries. So it means for my new colleague who wants to test it, and if they see, oh, you have virtual environment, you have requirements, it means we can install all libraries from requirements file. So for this one, yeah, for now we just have the requirements files. We don't need for our exercise, but we want to do it right. That's why we create requirements file. Okay, we don't need this. Now, next steps, we gonna create the folder. You remember the command make directory mkdir and name of the folder. So, and we can see we create new folder. We can see, oh, where we actually pwd, we here, what folders we have, or maybe you want to see the folders and the files, ls-la, we can see everything here. Nice, right? Because you know CLI, you can now do everything what I do, and it's very easy. But assume the case you have no idea what is CLI, I've never seen it before, it would be a disaster. So now, because we create the folder, we can change directory command, web app, we jump to there, and we can create the file with touch up Python file. And actually, we can skip this. We can just use vim app.py. It will do the same, but we won't do this just to practice a bit. So we can see inside the folder, I have the new file. It's empty. And of course, I can open the file and modify this, but it would be very easy for us. I will do vim, and this is the file. This is the file. There we can start insert the code. Because it's the vim, we need to first jump into insert mode, click I. I'm in insert mode. And now I can copy my code. Okay, I can click escape, exit from insert mode, and then I can write Qt. That's it. Now we can check, do we have any? Yeah, we actually have everything we want. That's nice. Okay, moving forward. Now we can test. We can first check, are we in the right folder? Yes. Do we have the Python code here? Yes. Now we can run the Python because I have Python free. It means I need to do this. And we can see, will it work? And we see it's starting the web server. And I can try to see, yeah, it's working, right? We see the hello world. That's exactly what we have. So currently it's working on our local machine. And what we want to do instead, we want to run the same from the Docker container. And we will do this. So now we'll move back to the root folder. Oh no, we actually don't need to move back. We will stay here. So we'll create the Docker file where we give the instructions. This is the Docker file. We have the open the Vim editor, or you can use the Nana. If you don't like Vim, you just use the Nana. And this is actual instructions for the Docker file. Let's copy them in. Let me open just readme and find my Docker instructions. Yeah, that's it. We escape, we queue, and now we have the Docker file. Oh, why I have two Docker file? Oh, because one of them is wrong. I don't understand what's the heck. So I have the Docker file, and every Docker file starts from the word from, and then we should specify the entry layer. What's the image, like parent image? And I'm using just the Python slim. It means like really tiny, very good for running the Python applications. So I want to create the folder inside. As soon as the container creates, I want to have the folder that will serve as my working directory. And then I want to copy all my code from this folder, right? Dot, it means the current folder. Because I'm starting it from the app folder, it will copy app.py and Dockerfile in it. The next, I want to run the command that I mentioned before. So if you want to install all the libraries that is here, so we just need to do this pip install and requirements.txt. Another thing, because the networking is also an important thing for our data roles, especially for engineering. But then we open this, starting the web server, we can see that it has port 80 by default. So HTTP without S, it sits on port 80 or sometimes 8080. If we have HTTPS, it's usually like secured with a digital certificate, and it sits on port 443. But it's outside of current scope. So, and usually then we expose the port 80 here. It's not because we actually open the port still not open. It's more for documentation purpose, because we can read those instructions, and if we see expose, it means we expect that this port will open in order to our application work properly. So we also we can create environment name, and okay, it should be like this. So we can pass inside the Docker container, we can pass environment variables, and from the CLI lesson, you know that environment variables is very good for sharing sensitive and credential information. But again, it's not the current scope. So, and then the Docker will be built and run. So it will start our application. So it basically will run the Python, and execute the program.ip. So the Docker will be running, because by default, in many cases, the goal of the Docker, so for example, if you want just run the Python program, for example, do 2 plus 2, right? That's it. As soon as the program is finished, it will shut down the container. But we want that the container continues to run. That's why we need to run the program, and this program will, as our example here, it will continue to run. So that's very simple Docker, and this gives you an idea how it works. Another file that usually useful to add, it's the DockerIgnore file. So from here I can add the DockerIgnore, and I want say that Dockerfile, or maybe it should be DockerIgnore. Yeah, it means the Docker file won't be copied to AppPy. Also, then we're using the Docker. In many cases, it's extremely helpful to mount external folder. Assuming you have the like Jupyter notebooks, and you may have the Jupyter notebook running in the container, but you don't want that all your notebooks or all your SQL commands be inside the Docker, because as soon as the Docker stopped, the data is gone forever. That's why often we can mount external folders and save the data like in those external folders. I won't do this right now, but this is just the idea for you. In the future, we'll have many examples of the Dockers. Okay, we have the Docker file that's simply instructions for us, and we have the program that's starting the web server on port 80, and we have DockerIgnore file with Dockerfile. So the next step for us is actually build the Docker. So to build the Docker, we should be inside the directory with the Docker. So we have our Dockerfile, and now I will go to the up folder, where is my Dockerfile, and now we can build the image. So the first one command we're gonna run is just the build the image in the current directory. And we can see what's happening there. And it tells me no such Docker. So it has the issue with reading my Docker file. And you see, because I have the typo here, and now the typo is fixed, so I can build it. And we see what's happening. So first it's okay, it load DockerIgnore, then it's starting to load metadata for the Python, so downloading the initial image. Then it's transferring context. So it can take some time. And because I have slowly internet. So here we have a bunch of CP requirements, and I can do it web app. That's it. So we see we just copy the physical file. And hopefully now we can build the Docker. Docker build. We can actually adding more information. We can say -t, maybe web app. We can add, this is my alias. I can also add the tag or version, for example, 01, and I can specify the folder. And see, you see, I even can run it from my root folder. So everything we succeed. So we can see, first we can try to click here, and we have one image and we have the tag. So tagging is very good and helpful when we work in production. In my case, now I can also see Docker PS, and I can see any containers. I don't have any containers. I only have the image. So my next step is to, as soon as they build, and you see there is variations of commands. We can just build. We can build with the name. We can build with the name and tag. And now we can run. So what we want to run, I can run. We can try it first, this one, and see what will happen. Oh, this is another type I have. Yeah, typo is the worst thing in our job. Okay, let's check it here. Invalid reference format. So if I go to web app and try to run it, see nothing there. So the way is to run it. What we need to do instead. So we don't need this command at all. We can run this because we have the name of our image, and there is also a command that can show us the image. So I go back to my folder. Let's do clear. I'm in this folder, and we can run this command. This command has port forwarding. We did expose just to highlight, hey, you need to use this, expose this port. And to actually physically expose this port is -p. And also in some cases, you might see that For example, we won't take port 80, but expose it to port 81 if port 80 is busy. So let's try to run it. Oh, big. Okay, it's looking for the image name web app. In our case, the image name we're using the same as so what we have here, this is port forwarding, this is web app container, name of our container, and this is name of our image. So we can double check. Yeah, the image is the same. Let's try to run it. And by default, it's trying to search latest tag. That's the same as is just how the standards works. So in our case, we have this tag. So now we can test if everything we did right. Yes. Currently, this is hosting outside of our container. You should have the same result. And we halfway through. So the next step for us is to check what is DockerCompose. In some cases, you may need to run multiple applications together, and they should be able to talk with each other. And for this purpose, we're using the DockerCompose. So my next step, yeah, I'm too far. My next step here is to, let me first show you this. This is only active containers, but maybe if I do -A, I can see all containers. And also, we can open our Docker app. It has all the same information. So it tells me the containers. If I click on these, I can actually connect it. I can open CLI inside container good for troubleshooting. We have the logs. Let's try run it one more time. There is couple other commands that I would like to do before moving to the DockerCompose. So let's so it tells me that the container name is already in use. So it means we have docker ps-a. We have the container that took our name. Even if it's not active, it still used the name. That's why one way of running container, we can pass the flag --rm. It means then container stop, it will auto-delete it. But in our case, we need to delete this container. And we can use container ID or container name. Okay. Now we should be good to go. Nothing else. So now I can launch again, and you see it took it make the busy my CLI. I don't like it. Okay, let's do again. Delete it. We deleted container. What we want to do when we're launching the container, we will pass a couple extra parameters. First is rm. It means then it stop, it delete. The second is -d. It means the detached mode. And it's applicable not only for the Docker. So now it's creating the container. Container is running. We can test it's running. But now it's not taking the window. Also, if we go here, we see it's green. We can take on the container. We see the logs. We even can open the CLI from here somewhere. Or we can open the CLI from here. So, for example, this command, docker exec, we can execute the command inside Docker. Or now I want to basically open the bash for this container. So I need to know the ID of container. ID of container is this one. So if I will copy this and putting it here, and saying I want to run the bash. Okay. It tells me no, so, oh, because I download the wrong container. I want to download this one. And voila, I'm inside the container. And now I can do anything I want. I can, for example, if something not working before publish to production, we can actually testing it here and see what's happening inside. So this is how we just finish, and we can exit, and we can see running container. And if I want to delete it, I can delete, or I can just stop it, doesn't matter. So we can delete the running container. We need first to stop it. I can just stop it from here. I forgot the command. So I can just stop it and I can delete. Very simple. Next step is, let's see where we now. We're inside the home folder. Let's moving to the DockerCompose. So we can create the file, DockerCompose, no typos, and then we can insert little snippet. This is the YAML file. The YAML files, they usually like .yaml with a, without a, they use for configurations. It's very probably the most popular file among all DevOps engineers. Data engineers using this as well. But for data analyst role, again, you need to know what each of those files means. What we have here, okay, escape, colon, write quit, and we have the DockerCompose file. So what it tells us, I'm not sure about any issues with indentation, we'll find out soon. But basically, it will consist from two containers. One is the version for web. It will search the Docker file inside web app folder. We do the port forwarding, and also it depends on another container. And for this, we just pull the image that is built by someone else. So we can, of course, build our own radius, but even for our case, we don't want to use it. But we want just to show you that example of DockerCompose running, the port forwarding depends on. So in here, we can define the network and run a bunch of things here, what you can do. But it's very good for starting purpose. So we have it here. And now we can try to DockerCompose build. So it will build the images first. As soon as it builds the images, sometimes we may need to pass no cache options if we want to completely flush and anything can rebuild the image from the scratch. Because very often then we do the changes in the Docker file and, for example, run the Docker build, it won't completely reload everything, especially it's very heavy. Because I know there's some containers, for example, AWS Glue, Spark, pretty heavy, and you don't want every time like download 500 gigabytes. So, and the next is DockerCompose up. So what it's doing, it's starting to creating containers. We can see, yeah, it works, and we can see how it looks like here. So we have different picture here, right? It has the name Surfalytics register, just the name of the root folder. We have two images running, Redis and web app. Even they're not connecting each other, it has the port binding, but this is how it works. And we can push -d and basically do everything else. Yeah, if I do click Ctrl C, I'm quit from here. So, and if you build the container, so it's stopping all containers. While it's doing, I can go to another window and I can see what I have here. I have one file modified and adding 3 new files inside the folder with subfiles. So here I have already black linting, so it should check my Python file and I should check all the YAML files. So if I will say git add, then I will do git commit -m adding Docker. You see it's a pre-commit trying to force, so it's changing my YAML files, remove trailing space, even a bit of modifying my Python file. So git, we should add again. Git commit -m adding Docker, git push, and we need to create a remote destination for us. That's it. Now we can go and create the pull request. And here we have descriptions of anything else we want, but I will just create empty one. It will end the merge pull request. That's it. We just merge the code. Another thing that I can tell you about the tagging since we started. So GitHub has releases, and we can create the new release. Also, if we go to the actions, we see that it's actually doing something here. So it's running our workflow, right? This is our pre-commit workflow, and it's doing exactly the same, but it has own descriptions for the container. It's built the container, pull the code of container, and then running the pre-commit. So it's all happening here, and it's pass. If not pass, we're not able to merge. And this is the place, like this is the continuous integration. The next thing what is helpful in GitHub is releases. So for example, they merge the code, but maybe we have the container that running remotely somewhere in production. For example, hosting dbt. We don't want to actually push this container to the production before drafting a release, because each version of the code might have the personal tag version. And this is where it's happening, creating new release. And here I can say, okay, let's create the new tag. I don't have any. v100, and it even can generate release notes. So, and I click publish release. That's it. Just now you learn what is releases. The idea of release that our code has the tag v00, and also it has the tag is latest by default. So whatever applications using our code, we can say only use the latest or the certain version. This is how we also can split testing environment and production environment. But about this we'll speak in the future. So for you as a tip, then you see in your new organizations or current organizations releases and the tags, you can see this your organization using them. Yeah, and the last thing what I want to show you is the Docker registry, where we can find many. It's DockerHub, it's registry where you can find many images. For example, Metabase, right? This is open source BI tool, SQL friendly, very good. We'll learn these. Another one is Spark. It's Apache Spark, very powerful for data engineering. We'll learn this as well. Airflow, I bet they have Airflow image here. Yeah, this one, Apache Airflow. Superset, it's another popular BI tool. Or do we have dbt core? No, they don't have dbt. And it's fine because it's just one Python library. Let's check the Airflow. Where is this Apache Airflow? If you go here, we have all the definitions, so we can build our own Airflow image for orchestration of data pipelines, but instead we can just pull and download the image and start using this. We also can look for the source code of these. So if I click GitHub Airflow, we can jump to their repo. You see it's a bit more complicated. We can click what's the Dockerfile, and it has way more information, right? Theoretically, you can clone this Dockerfile and be able to launch, but you see it's the Dockerfile could be complicated. But for you, just if you know where to search and what to do, then you're able to do this. But for end users who want to use the Airflow, we'll just pull the image and start. That's it. That's it for this lesson. I hope it was helpful. And after this, we actually start learning analytics things like data analysis roles, BI roles, data engineering, and everything else. Thank you.